Hi, my name's Stewart Lynch, and in this video I'm going to introduce you to SwiftUI's MatchedGeometryEffect. I'll show you how you can transition from one view to another with a smooth animation. You'll learn about the namespace property wrapper and the MatchedGeometryEffect method that utilizes the namespace and matches views with identical IDs. We'll see how we can match either the size, position, or the full frame to transform from one view to another, and even specify different anchor points. If this is something you want to learn, then keep watching. I love getting your feedback, so tap the thumbs up button if you enjoyed this video and leave a comment below. Make sure you subscribe to the video and ring that bell to get notifications of new videos. And if you want to support my work, you can buy me a coffee. Normally when I research a topic for a video which I want to create, I read a lot of different blogs, books about the topic, and watch a variety of different videos. Then I come up with something that I can present in a structured, logical way to my viewers. And this topic was no exception, except that I found that almost all the resources I checked only scratched the surface of the MatchedGeometryEffect method and didn't really cover the topic that well. That is, until I read this chapter in Mark Morgan's SwiftUI Animations Mastery book. I have a link in the description. And those of you who know me know that I'm a huge fan of Mark's books, and I recommend them highly, particularly if you learn better from reading rather than watching videos like mine. This chapter was so complete on the topic that I reached out to Mark and asked if I could use his approach to the topic in my video. Why change things if it's working? He not only gave me the go-ahead, but also offered to provide me with a code for a free copy of the book for one of my viewers of this videos. So if you're watching this video and stay with me up until the end, I'll let you know how you can submit your name for a chance to win the book. MatchedGeometryEffect defines a group of views with synchronized geometry using an identifier and a namespace that you provide. By this, it means that between two views or groups of views, you can match up the geometry, which is size and or position, and provide an effect to render those changes when you transition between the two views. The type of objects can be completely different, but the objects that you are trying to match up have to be assigned to a common namespace with the same ID, and only one of those views or groups of views can be visible at one time. To get a better understanding of what this really means, let's take a look at this example. I have a V-stack, and within the V-stack, an H-stack displaying two rectangles. The first is filled with a blue color and has a frame of 150 by 100. The second is another rectangle filled with green at an opacity of 0.6, and you'll see shortly why I set that opacity. The width is set to 100 and the height to 50. I'm going to start rather unconventionally here with an example that is not normally what you will see in a tutorial or blog about GeometryEffect. I'll show you one of those in the second example. This first example, however, introduces you to a number of arguments for MatchedGeometryEffect that are not normally covered, but will help you understand or troubleshoot when you implement in your own projects. I'm going to create a namespace and assign it to both of these two rectangle views. A namespace is a dynamic property type that allows access to a namespace defined by the persistent identity of the object containing the property, e.g. a view. We create one using the @namespace property wrapper to create a variable that we can assign a name to. Now, since I'm only going to use this within this struct, I'll make it private. If I option click on the basic NS variable name, you'll see that it is a namespace.ID type. Well, now that I have a namespace, I can use it to initiate a MatchedGeometryEffect on my two views using the MatchedGeometryEffect view modifier method. And we do this before we set the frame on our view. The only two requirements for the MatchedGeometryEffect are the ID, which can be any hashable type, and the namespace, which is a namespace.id. Well, we have that namespace, and for our ID, we can simply choose any string, like basic. If we assign the same exact method to the second rectangle, something strange happens. The geometry for that second view changes and now matches the geometry of the first view. The size has changed as well as the position. And we can see that the opacity of our green rectangle is showing that the blue one is right behind it, exactly in the same size and position, the same frame. I'm also getting an error displayed on the console, where multiple inserted views matching the geometry group, the basic one, have isSource property set to true, and results are undefined. This could lead to some pretty serious problems later on. Why is this? If we option click on the MatchedGeometryEffect, we see that the function definition, there is an argument called isSource that specifies that isSource is true, and the error is telling us that only one can be on the screen at one time. So let's add that argument in the end and specify that isSource to be true for the first rectangle, but I'm going to set it to false for the second. Well, this doesn't change the effect of our view. Let me clear that error and toggle the live preview. When we toggle back to live, we see that we no longer get that error. Now, if I remove the ID from the second rectangle, we get both views because we're no longer looking at matched items. The IDs and the namespace have to be identical. When I add it back, we see the overlap. Well, we can animate the transition if we want, and that's the third part of the MatchedGeometryEffect. What kind of effect do we want to transition from one to the other? So let's create an @state property called move. That's going to be a Boolean value that we'll set to false initially. Then in the VStack, I'm going to create a button with the label move. And for the action, we'll toggle that move state property. And then for the second MatchedGeometryEffect method, I'm going to use the ternary operator to change the ID based on this state. So if it's true, it will be basic. If it's false, it's going to be an empty string, so therefore we won't get matched. So now as we tap the button to toggle the state, the rectangle moves and changes size. The power of MatchedGeometryEffect and SwiftUI, though, is to add animation to this change of state. So let's do that. Well, that's pretty nice. But you can make it even more effective by giving it more custom animations, like a spring. But I'll leave that up to you. The key lesson here is that when you have two views on screen with the same namespace and ID, the view will transition from the source, where the source is false, to where the source is true. And you can see that when I switch these two up. Well, let's revert back to the original version though, and move on. We still have two more arguments to explore, as I see when I go back and option click on the method. The first one is the properties argument, which is a MatchedGeometry properties enum, and it's set to .frame in both cases. And you can see from the documentation there are three cases. We have frame, position, and size, where frame is both the position and the size. So let's make it easier first for us to see what we're doing here by separating our arguments in our method. The properties argument comes after the namespace argument. So let's add that in, and we'll use the default frame for both, and you'll see that nothing changes. If, however, I change the enum to one where isSource is false to be size, then we see that it only changes in size, not position. It matches the size of the source object where isSource is true. If we change this to be .position, the size doesn't change, but the position matches the position of the source object. And this is the key of the final argument. Where is it anchored? If we check the function definition once more, we can see that the anchor property, that is a unit point, is set to .center in both cases. Reviewing the documentation then, we can see that the unit point enum can be any one of these different unit point locations. So let's see what happens if we change that anchor value. For the source rectangle, I'm going to change it to .top leading, but I'm going to let the other one stay at center. So the green rectangle's center moves to the top leading edge of the blue rectangle. If we change both to top leading, then the top leading corners match up. Well, you can play around with different combinations, but I think that you can see that you will have some control as to where your objects will move to. For example, what if you specified that the source anchor was bottom leading and the moving one is top leading? Can you picture where that will end up? As I said initially, this isn't a typical introduction to MatchedGeometryEffect. I think you'll find that the next example is, however. Well, now that we have an understanding of what namespaces are, I want to go through a couple of examples as I try to improve the UI for this set of views that I have displaying images and information about the Joshua Tree National Park. Except for the header image, which I took myself when I was there recently, all other images are from Unsplash, and I've used the author's name as credits in each of the assets that I have loaded into my assets folder. The UI is driven from site view, and I have a header view here that displays an image along with a title and a tagline for the park. When I tap on the header, it changes to an extended header view with more information. And you can see that in the code here, this is driven by a tap gesture and a Boolean show extended state property that's initially set at false. So the normal header view is presented. When I tap on it, the state changes and we're presented with the extended header view. So in no case are these two views displayed at the same time. It's one or the other. Now I pass in a site from a view model in each case so that it can present the image and other properties of that site object. And that site object has 6 properties, and one of which is an array of strings representing the assets that I have in the assets folder. And I've also created a sample object to use in my code. So we're only representing this one site, this Joshua Tree National Park. The site view model is pretty bare. I have a published site property that simply initializes our sample. And that's all we need to look at here for the first part of this section. The other properties and functions will be handled in the second part of this section. The header view and the extended header views are SwiftUI views that represent the two states of our header. And what I want to do is to use MatchedGeometryEffect to transition between the two views in a much nicer way. And we can do that with a namespace and a MatchedGeometryEffect method. So first, let's create a namespace in our site view that we can pass on to our two header views. So let's call it Site NS. Well, this is a namespace ID property. So if we're going to pass this on to our two header views so that we can match up our views, we'll need to create a let property in each. And I'll do that at the top. And I'll use the same name for our namespace. And then to stop the preview from complaining, we can create a static namespace property and use it in the initializer. And I'll need to repeat that same process for the extended header view. So now let's return to the site view and change it to add this new property when we present these two new views. Well, nothing has changed so far except that we've now got the same namespace in two different views. So we can start to match up the geometries of different parts of those two views with IDs and let the MatchedGeometryEffect handle the transition for us. Well, since only one of these header views are going to be displayed at one time, you don't have to worry about the isSource property, as it will be true for the visible and resulting view. So if we create and use the same ID for each view that we want to match, then it should just work. So first, let's just handle the image alone. I'll apply this MatchedGeometryEffect method just before the frame in each case. And I'll create an ID using the string image. So in the header view, we can apply this method using that image string for that site NS namespace. I'll need to do this in the other view, so let me just copy it here and apply that same modifier in the extended header view to the image here. If I test this now, I see the transition is nice and smooth for that image. I don't, however, like how the title and tagline just appear. So I'm going to fix that here now. Well, in the header view, where we start, I'll attach another MatchedGeometryEffect method to the VStack for the same namespace, but I'll just change the ID and I'll use the string text. So once again, I'll copy that here and apply that to the VStack in the second view as well. Well, this isn't exactly the effect that I wanted. That extended text is additional in the second extended header view's VStack, and it's getting in the way here and messing things up. So what I'm going to do is go to that extended header view and enclose those first two text views in its own VStack and apply the MatchedGeometryEffect just to that VStack. Well, it's almost working, except that the text for the extended information is appearing too quickly. I want it to appear after the transition. So to do this, I'm going to create a state property in the extended header view, and I'm going to call it showText and set it to false. Then I can surround the text view for the site.extended in an if clause and only display it if it's true. So we can then create a delay when the view appears. So I'll use that with animation with a linear animation with a delay of 0.3, and then I'll toggle that show text property. Testing now, I'm getting what I'm looking for. For the second part of this section, I want to improve the display of my images. Currently, when I tap on an image, a modal sheet appears and displays the image and the image creator's name in that sheet. Initially, the selected image is nil, and this is handled by an onTap gesture that calls the selected image function in the view model and passes in the image that was tapped on, and that's just a string. It then toggles the show image boolean property that presents the selected image view. This then gets the entire view model so it knows what image to display, and since it's not nil, it will present the selected image, and then the tap gesture will call the view model's unselect image function, which will set the selected image back to nil and dismiss the view. In the site view model, there's this selected image that's an optional string set to nil, and our two functions currently just set the selected image or return it to the nil state. I think I can do better than this using a MatchedGeometryEffect. I don't want to use a modal sheet, however. I just want to transition that small image in the grid view to a selected image view showing right on top. So I can use a Z-stack to do that. So in Site View, let's remove the sheet modifier. And then I'll embed the V-stack inside a Z-stack. And then as the second or frontmost view on the screen, I'll first check to see if the view model's selected image is not nil, meaning we've tapped on something, and then present it, making sure I pass in the view model. We can return to the selected image view then and remove the environment for the dismiss and the dismiss action in the onTap gesture. If I test now, I'm getting something, but there's an issue in that I can still see the scroll view behind it. Now, I don't want to completely remove this from the view because if I'm scrolling down the list and I tap on it again, I want to be able to keep that scroll position when I introduce the MatchedGeometryEffect and then return back to this view. So I'm going to apply an opacity to the school view based on the state of the isSelected being nil or not. So if it's nil, meaning nothing's been selected, we'll set the opacity to 1. Otherwise, once selected, it will be 0. Now I'm getting it here, but that dismiss is rather abrupt. So let me return to the selected image view. So I'm going to add some animation here around the onSelectImage function call. Let me test this now in the simulator, because sometimes viewing in the preview, you don't quite get the animation effects. Well, it's kind of working, but it's not really slick, and I don't really see the effect of that spring animation when I dismiss the image. Okay, we're set up now, though, to perform the MatchedGeometryEffect magic. You'd think that all we need to do is match the geometries of these two images using the image name as the ID for the MatchedGeometryEffect. So let's just try that. So we'll need to create a MatchedGeometryEffect method using the image as the ID, because it's going to be unique each time. It's the selected image. Remember that it's a unique string representing the name of the image asset. And we can use that same namespace. I'll add that before the tap gesture for the selected view. And if we're going to use this namespace in our selected image view, then we'll need to pass it on. So where we present the selected image view, let's pass it on. However, this complains because the selected image view is not expecting it. So we'll need to fix that. First, as we did with our header view, we'll add a let property for our namespace ID, and I'll give it the same name of site_ns. And then again, as before with our header views, I need to update our preview by creating a static namespace and adding it in to the selected image view in the preview. Well, now that that's in place, we can apply that MatchedGeometryEffect method to our selected image, where the ID is going to be the selected image, which is the same one that we had in the previous view in our site namespace. If I run this in the simulator now, it's looking pretty good, but there is a bug, and it's a big bug. We're getting an error every time we present an image. The reason is that we really have these two images on the screen at the same time, and both of them have the isSource property of the MatchedGeometryEffect set to true. And the image is still there in the school view, even though the opacity is set to 0. So the solution, though, is to remove the image from the school view when you tap on it, and then put it back again in exactly the same index location in the grid when you're finished. And this also gives us an additive effect bonus, as you will see, that looks like the image is being pulled out of the grid to be presented. So back in the site view model, we'll need a property to remember the selected index. So we can create a new one as a published property and initialize it at 0. Next, in the selected image function, we can remove the image from our image array, and then when we unselect the image, we'll add it back at the same index. So in the selected image function, we'll first unwrap the index using an iflet to find the first index from the site's unsplash_images array where the image matches the one that was passed in. Then we can set the selected index to that index. And then we can remove it from the unsplash_images array at that index. And then finally, we can set the selected image to that particular image. In the onSelectImage function, then, we can unwrap the selected image using an iflet, and then insert it back to the selected index. Prior to doing that, however, we'll need to set the selected image of the class back to nil. Let me test this out now again in the simulator, and I'll see that it works and no errors are displayed, and I get a pretty nice transition both ways. And even if I scroll down to the bottom of the grid and tap on an image, it gets removed and displayed, but when I dismiss that full view, we see the school position was kept and the image gets inserted back in the same spot. Before I leave you now, I just want to bring you back to Mark's book. This chapter on MatchedGeometryEffect is close to 100 pages, and he points out all sorts of issues that he had and how it's not a perfect API. He provides you with tips and tricks and tries to address all edge cases, so I highly recommend that if you're implementing MatchedGeometryEffect in your app, you get this book and work through his examples, as there is likely an example similar to what you want to do. He even has a lazy V-grid example like mine too, but he handles it differently from me, so make sure you give it a read. As I mentioned at the beginning, Mark wants to give away one of these books to one of my viewers, so on June 18th, 2023, the day that this video is released on YouTube, I'll be accepting an email to the address shown here up until midnight, my time, and I'll draw from all submissions and announce the winner the next day. Well, I hope you've learned something from this video and can imagine implementing MatchedGeometryEffect in your own projects. If you've enjoyed this video, please give it a thumbs up and leave a comment. It helps drive more traffic to my channel. And be sure to subscribe and enable notifications so that you're aware of new videos when they're released. Thanks for watching.